PRD and SRD, those are I'll call them design documents.
Design input documents.
Yeah, they define what the product is and how it functions.
Right.
What we're talking about is manufacturing documentation, which is how to put the product together in a repeatable, reliable way.
Right. So you got design, you got design input, the PRD, the SRD, design input documents, and then you have design output documents when the design's all done. And the design output documents are roughly equivalent to the manufacturing input documents. A bill of materials, for instance, which lists all of the components down to the lowliest screw. Drawings of custom components, specification of off-the-shelf components. That's all design output, and it's necessary for manufacturing input.
So just to kind of scope the manufacturing documentation. So when you say that term, it's pretty broad. So there are definitely documents that are in place to show you how to build the product, right? You've got assembly drawings, assembly procedures, potentially in-process inspections or test procedures, calibration procedures, all that stuff. But it starts a little bit further back. Manufacturing documentation, in order to be able to put these parts together per the assembly drawings, you need to get the parts. And there's definitions for those parts. As John said, the BOM can get you a certain amount of the way there. Mostly for COTS materials, you can usually define COTS materials with a manufacturer and a manufacturer part number. But that's manufacturing documentation. And then to go the custom component route, you have to be able to define all of those custom components to your suppliers so that they can give you the parts that you intend to build using your assembly documentation. So you've got custom part specifications, or in the case of like circuit boards, there's a whole package that goes into defining how to get a board delivered to you, PDFs of all the holes that need to be drilled, the material, the copper layers, the pick and place, the Gerber files. There's just a mountain of files that go into making a printed circuit board, a custom printed circuit board. And you can go all through it, but generally manufacturing documentation starts with the component specifications to get the parts you need to get in order to build to a manufacturing process to build the product. So it's manufacturing documentation is a very broad term as far as the process goes.
Yeah, what we find is there's a pretty long list of the kind of documents that you need to send to the manufacturer. Bills of material, component specifications, custom component detail drawings, assembly documentation, the process, how to put it together, test documentation, the how do you test it to make sure that it's done, calibration information. But the very first things that you need to come up with are the component definitions and custom part drawings and a schedule, because there's always a lead time to order these components and get received by the suppliers. Whether sometimes, off-the-shelf components are in stock and can be delivered in a week, those aren't the ones that you would attack first. You would go after the custom components that need to go to a machine shop, or if there's a molded component and we have to get a mold made, we're talking a few months to get the mold made, and then to get parts in to validate that the mold is correct, and then you can begin to order the molded parts. So it could be 3 months before you'll get molded parts in. Machine parts are usually on, I mean, you can get them in 3 weeks if the machine shop isn't busy. 6 weeks is more realistic.
3 days that you really want to pay.
And you can pay to get it expedited, but pay you will. If there are a lot of machine shops like in China that will, take electronic files and send you the parts, and you'll have the parts in a week, and they're expensive. They don't necessarily conform to all those little details that might be on the drawing, like the tolerances, because they're just sending it out to a CNC and pushing a button, and the CNC is spitting out the product, and you kind of get what you get. But in many cases, that's good enough. But if you've got some high precision work, that takes a little bit longer, and it requires a drawing along with, say, a step file in order to get it done.
Right.
So the very first thing to do is get all of the components on order. And there will be some that are long lead time, and those are the components that are going to dictate the schedule. The ones that are in stock are not the ones to worry about. I mean, there might be an impact from a cost standpoint, but they're not the ones that are going to delay the issue. The idea is identify the components that are long lead, get those drawings done first, get those components identified first so that they can get on order immediately. Those would be the long lead components. Then next, the normal, a couple of week off the shelf components can be ordered. And then when they start rolling in, say 8 weeks later, that's when you need all of the assembly documents so that you can begin to do the assembly. So first the component definition documents, and then next get the assembly documents. And then right after that, you get the test documents, depending upon the order of the manufacturing process.
Yeah, and one thing that I think gets a little overlooked is when you're building a product, you have to, in order to create a complete set of manufacturing documentation, you have to define where that part is going to go. So you have to define an entire part's life, within a manufacturing process. So you have documentation that you need to get the parts, to order the parts, right? But then the parts have to come in, they have to be received, they have to be handled in some way, and depending on what type of part it is, it will be routed in a certain way, and we have to set up that routing. We have to set up a COTS part takes a certain route. It gets received, it gets counted, and then it goes to the stock room, because it's a COTS part. It's commodity. It's there are usually less checks and balances that we have to have in place because you're ordering a part number. It's pretty standard. But custom items, they have to be routed through our incoming inspection, because we need to qualify our supplier in that, did they build what we asked them to build? And did what we asked them to build, is it what we actually want? So it has to go through an incoming inspection. So if you imagine one, call it custom part in a product, we have to define the entire route that it has to take. So it has to be designed, has to get ordered, has to get received, has to be inspected, has to go to the stockroom, get kitted, go out to the floor, get assembled in a certain way, get tested in a certain way, and then get shipped in a certain way. And there's an entire process for that one part. And then you have to do that for every part. We leverage our computer system to do a lot of it, but it's all there. It's all encompassed in how to manufacture a product well and repeatably. We have to define those paths for every single part. It can seem a little bit trivial to someone who may not be involved in it every day, but if you just get a heaping pile of parts, based off a design, and then here's a bunch of documentation, go build it, the first thing someone's going to ask is, they're going to go, well, I don't know where this part is, and I don't know how many of them I need. There's a bunch of other documentation that may not be on the assembly drawing itself, and it may not be on the part spec itself, but it's supporting documentation that allows those parts to come together in a certain way at a certain time.
It's interesting. Once you start thinking about it in a certain way, a lot of this becomes clearer. Anybody can build 5. You get a pile of parts, you root through them, you find, yep, this is the one that I want. You bolt it on, and you build one, and then you build the next one and the next one. Anyone can build 5. I mean, it just takes maybe a couple of days and some screwdrivers, and if you're the person that understands what the product needs to be, yeah, you can build them. But if you want to build 500 and you want the 63rd one and the 482nd one to be identical and perform properly, you've got to have a process that allows that to happen. A person, even someone extremely familiar with the product, cannot do it repeatedly unless there are process control points in place and a defined process. At first, that part goes on there, and it is aligned exactly like this. And then some other part happens.
Yeah,
That stuff has to be defined.
Yeah, any given part that comes into our building, I'm thinking 1, 2, 3, there's probably 7 or 8 people at a minimum that interact with this part. And not every one of them is going to know what this part is, what it goes to, what's important about it, what it is, what does it do. They're not going to know that, and they're not expected to know that. So like John said, anybody can build 5 if they're familiar with the product. And that's what we tend to do in engineering. We designed it, we want to qualify that design, we'll get a pile of parts and put them together because we're familiar with it. But when you're setting up a manufacturing process, I always think of it like you have to set up the process in such a way that somebody who knows absolutely nothing about the product can put it together and qualify it the way that it's meant to be put together and qualified. So that starts at purchasing. Purchasing needs to be able to buy the parts, the correct parts, every time without having any idea what that part does. They just need to be able to go buy it. And then receiving, inspection, inventory control, all of those different departments, different people, they may not know what these parts are and what they do and where they go, but they need to know how to process all these parts in such a way that gets a full product.